What's up, everybody? Let's continue on with our higher power polynomial. These are really fun stuff. If you just dig into it, you get to get more out of it. So let's go ahead and talk about remainder theorem quickly. Remainder theorem. Today we're talking about higher power. Still, higher power polynomial. Okay, remainder theorem is really saying, if I have some polynomial and then I'm going to divide this by some other number, like x minus some other form, first power polynomial, x minus some number, then this remainder is same as plugging r into that function. So let me just explain using an example. Let's say we have f of x, some higher power x cubed plus 5x squared minus 9x minus 7. Okay? Let's say we have that and I want to divide this by some other first power polynomial, x minus 3, right? I want to divide by that. So they're really asking you to do long division here. So I'm not going to do the long division. You guys can do it if you want. If you do this, you're going to get some second power form here, and then at the end you're going to get a number, right? That number, that remainder here, is exactly same as f at 3. Not minus 3, but 3, right? So let's just get that. Get the remainder by plugging in that 3. Then we get 3 cubed plus 5, 3 squared, minus 9 times 3 minus 7, right? So we get 27, and that's 45 minus, well, you don't have to do that, 9 times 2, 18, and minus 7, 20, and 38. So we just found the remainder without having to go through the long division, right? This tells you that 38 will come out here. Amazing, right? So let's write down that stuff here. Remainder theorem. Remainder theorem, it says if I divide f of x by x minus r, the remainder is same as f at r. Good, that's the summary. All right, we just did that example, so let's look at the next one. Number 2, factor theorem. If r is the 0 of some function that we have, then x minus r is the 0 divisor with no remainder. Good. Divisor means there's no remainder. All right, next thing, let's talk about factor theorem. Factor theorem is saying that if r is a 0 for f of x, which means when I plug in r into f of x, then you get 0, right? Then x minus r divides f of x without any remainder. So it's really saying this. R is a 0 of f of x, which means when I plug in r into the f, I get 0. Then it's really saying exact same thing as the remainder theorem. It's saying that this thing f of x, x minus r, it gives you 0 remainder. Now it's going to get something, but no remainder. You could change this sentence this way. If r is a 0 of f of x, then x minus r is a factor of f of x. So let's do an example. I think it'll be better to give an example. Let's say we have f of x given as x cubed minus x squared minus 4x plus 4. Okay, something like that. And then let's ask ourselves, is x minus 1 a factor of f of x? The answer, you can do it different way, actually dividing by it and see that there's no 0, no remainder, but you could just plug in that 1 into the f of x and then see that it gives you 0, that 1 is the 0 of this function. So 1 cubed minus 1 squared minus 4 times 1 plus 4, it gives you 0 here and 0 here. So we just found that 1 is a 0 of this function, therefore x minus 1 is a factor, right? So this is one of the ways you can use them. And the third kind is rational zero theorem. So